Good day, everyone. Thanks for being here today. I'm Dave Rubenstein, Editor-in-Chief of SD Times, and I'd like to welcome you to today's SD Times live webinar, Enterprise Observability Behind the Term. Before we get started, I have just a couple of quick announcements. First, today's presentation is going to be followed by a live Q&A. So if you have any questions at all throughout the session, just go to your control panel, the questions tab, type it in, hit submit, and we'll get to as many as time allows. Secondly, we'll be recording today's session, so it'll be available on demand on the SD Times website starting tomorrow for you to play over and over again to your heart's content. Okay, enterprise observability behind the term. We've written a lot about observability in SD Times in recent months, and people have come to understand it as an enabling technology that allows organizations to look into their applications and systems to see how they're performing and to find and remediate problems that affect that application performance. So here to dive more deeply into it and look behind the term are Chris Latrichia from Instana. He's the offering manager there. He's a data center engineer for 17 years who became an APM specialist. Also with us today is Drew Flowers. He's a senior solutions engineer also at Instana. So here to kick it off now, I'll turn it over to Chris.
Yeah. Hey, everybody. Good morning, good afternoon, good evening, wherever you may be today. If you're in the United States, I hope you're keeping cool out there. It's pretty hot across all the country, as I understand. Pretty bad, particularly in the Northwest right now. So I hope you got whoever you are, I guess, I hope you got a bottle of water with you and you're keeping cool this summer. Once again, my name is Chris Latrichia. I work here at Instana. I'm joined today by my buddy Drew Flowers, also of Instana. We're here today to talk to you about a little thing called enterprise observability. We're going to go a little bit behind that term since it may easily seem like a buzzword. This presentation today is aimed at kind of being a little bit of a funnel style conversation. We're going to start off at a high level with a PowerPoint presentation that's going to get more in depth as we go on. And then we're going to end our presentation today with some live demos to talk about what exactly we mean by enterprise observability with an example of an enterprise observability platform. So to start off, I just want to set the stage with the definition of observability we've all been working with for years. This really shouldn't surprise any of us, but I just kind of want to lay the groundwork of where we're coming from for our baseline. According to our analysts, observability means you have access to all the data you need, logs, events, metrics, traces, and dependency maps for every single unit of work that your application and its underlying infrastructure perform that is of interest to you and your business. Now, you may have a little bit of a different personal definition, and that's completely fine. This isn't meant to be verbatim to get us all in exactly the same spot. I just want to kind of lay the groundwork of where we are to start off this presentation. In that space, we've seen three tectonic shifts over the past couple of years, and it really all boils down to the demands of digital transformation. Digital transformation has brought on these three shifts in the way that organizations are managing their applications. These three shifts are all related to each other, as we're going to outline in our presentation. And it really all starts with deployment frequency. That moves on to organization and the move to DevOps, and that also equals technical complexity and almost endless dependencies. And that all creates the need for enterprise observability. So let's dive into the first one, deployment frequency. Development teams are being required to innovate more and more quickly to keep up with customer expectations. I'm sure everybody here has felt that at some point or another, and that results in constant change that can be really hard to keep up with a lot. Well, we're trying to run this DevOps loop we see on our screen as quickly as possible. We're also trying to keep our change failure rate low, and we're trying to keep that number pretty constant. So the amount of failures within this loop, we're trying to keep low and we're trying to keep constant. Optimally, that number is 0. That's probably not realistic, but we're trying to keep it low regardless. In either one of those cases, trying to run this loop faster and keeping our change failure rate low, monitoring can be a little bit of a hindrance to that right now. We have a bottleneck because usually other spaces within this DevOps loop are either automated or can otherwise be run pretty quickly. Monitoring right now is a little bit of a manual task, and we'll see later on in our presentation that that's really becoming a drain on a lot of organizations. So in response to all that change, organizations are reorganizing the development operations teams to work more closely together in the term we call DevOps. Traditionally, I'm sure we're all familiar with some type of derivative of the meme on my screen where it worked fine dev, it's ops operation, it's ops problem now, excuse me. And obviously depending on what side you're traditionally on in this meme, your thoughts are gonna be a little bit different. We're at the point where we're no longer that meme. We're combining dev and operations together. That means we're sharing each other's work. The biggest problem is we're sharing each other's problems now. Developers are responsible for their own applications in production. And because of that, excuse me, they are empowered to choose the tooling that works best for them and their individual needs. The problem is that results in tool sprawl and multiple similar technologies within an application environment that do almost the same thing. So you have a variety of tools that overlap. As if that wasn't enough, and compounding on all that, those DevOps teams are now breaking down their monolithic service-oriented applications and turning them into cloud-native microservice application environments. Those environments exponentially increase the amount of technical complexity the teams have to deal with. Endless dependencies make it nearly impossible to make sense of all the data that's coming in from these individual microservices. So doing things like finding root causes of issues is drastically more difficult, as you're really not able to determine any dependencies across your absolutely crazy systems. There's no other way to verbalize that. For instance, how are you supposed to know which service is causing an issue and what the upstream and downstream impacts are when it's really not possible to show an architectural diagram of where your application is in the first place? As we can see up on our screen, this is an actual map of a very complicated microservice environment. Try figuring out what's going on with that. It's not easy. To compound on that problem, we have more technologies now. And again, if you're a traditional developer, that's fantastic. We love more platforms and more technologies, right? Kubernetes, Cloud Foundry, this is awesome. Maybe you have like, Tanzu, for instance, and you can sink your teeth into it. That's awesome. Traditionally, operations isn't too fond of that because now that means they have to monitor it and they have to keep it running, which is fantastic. That results in something I call the 3 a.m. problem. The 3 a.m. problem is exactly like it sounds. So if you have a problem with your environment and it goes off at 3 a.m., you're gonna have to figure that out. If your environment is very complicated, that means you might be sitting at your computer from 3 a.m. to 5 a.m. trying to figure out what that problem is with all your new tooling that you don't necessarily understand, your new platforms and your new microservice environment. So your 3 a.m. problem becomes, could be a 3-hour ordeal. On top of that, it's now duct tape time. As a result of all your new technological complexity and all your problems that go with it, most of your environment is going to be duct taped together. And we probably all know what this is like too. You might be looking a little bit like Jamie Heineman here on his duct tape raft. This is kind of what your world is starting to look like because it's so complicated and you're just sticking things together. So The good news is we have solutions to solve some of those issues already. Up on the screen, we see screenshots of Prometheus and Grafana. Now, the purpose of this slide is not necessarily to call out Prometheus and Grafana. First of all, I'm an open source guy by trade. I've spent the last 5 or so years in open source, so I would personally never knock open source, just as a rule. We also at Instana, we support observability, open observability, platforms like Prometheus and Grafana, so you don't have to totally throw away your work, right? You don't have to rip and replace with new observability platforms. But what I do want to point out here, and Prometheus and Grafana can be examples of this, is that we have applications now that can get you all that data. The problem is there's lots of data, and we'll point that out later on in the presentation. There's also this little asterisk here, is that manual connections and configurations to all this data that you're flooded with are unfortunately going to be necessary when you're using some of these platforms. And that creates a little bit of a problem. All those manual steps are going to slow you down. These days, monitoring requires your best engineers. And that's a little bit of a problem because that takes up a lot of time. They're going to have to manually write data collectors. They're going to have to manually instrument code for tracing. They're going to have to manually configure those data collectors. I mean, the list goes on of things that you have to do all by yourself. That accounts for a massive amount of time for those engineers. It also amounts for a massive amount of brain power. Like I said, those can be some of your best engineers that are occupied just doing monitoring. And all that's going to burn money on top of it. So monitoring these days can look a little bit like this guy on our screen for everybody involved. For engineers, they're busy configuring, connecting, writing observability code, and setting up. For managers, all their team's time is being taken up by this thing called monitoring that is really not the main job when they're supposed to be putting up applications. For the bosses of them, well, that's a lot of money that's being thrown down the toilet. And again, as I alluded to, meanwhile, nothing else is getting done. So this creates a little bit of a problem. What can we do to fix that problem? Well, there's 3 things that can fix that problem. First of all, we can automate the discovery and configuration of everything within an environment, so you don't have to spend time setting things up on monitoring. Second of all, we can turn all that data that is being consumed by platforms into contextual information. That enables something that we call intelligent action, so that you can get the right data and fix the problem. Those 3 things are something that we refer to as enterprise observability. So remember that slide a little bit earlier where I said manual steps slow you down and you would have to manually write data collectors, configure data collectors, et cetera, et cetera. Well, first of all, as an engineer, you have better things to do right now than to be worrying about that. You should be focusing on things like innovating and moving your company forward and delivering business value, which, maybe your boss wants to see, maybe your boss's boss wants to see. This accounts to another thing that I like to call the observability burden. The observability burden, as I think we've outlined in this presentation so far, is the massive amount of time, effort, and money that observability can take. With automation, we can help lift that observability burden, because observability doesn't have to be like the slide on this screen where it burns up time, money, and energy. So to do that, we can automate all the things. We can automate the writing of data collectors. We can automate the configuration. We can automate the building of data collection to store metrics, et cetera, to take that off of the shoulders of engineers so that they can do other things. Secondly, let's talk about data. It's not just about having massive amounts of data from your platform, it's about what you do with it. Data for the sake of just having data is honestly absolutely useless. So we're going to need to contextualize relational dependencies to understand how every component or service interacts with every other service or component. Now, just like automation, the need for contextualization isn't really a new problem. But again, just like automation, it's exacerbated by larger and larger amounts of data. Again, if we think back to our 3 a.m. problem, it's not just enough to know that there's a problem happening at 3 a.m. Fantastic, there's a problem happening, it woke you up, it's 3 a.m., you don't want to be awake right now. But if you think about that scenario, you would really want to know why a problem's happening and how you can go in and fix it really quickly. So you don't have to stay up till 6 trying to figure it out. And who knows, you maybe even leave it till tomorrow. Second of all, if you're going to be responsible for a service performance, particularly in dev, you should know that you're getting the right data, first of all, not just mass amounts of data that may not be entirely relevant to your problem. Lastly, we can enable something called intelligent actions. And that's really the last piece of the puzzle. Intelligent action is what allows you to move forwards and stop fixing problems and start building. Intelligent action is what also turns your 3 a.m. problem into a 5-minute quick solution. Again, it gives you the right data that you need to answer the problem to tell you exactly what's going on. So kudos on having more sleep, because you now have enabled intelligent actions that allow you to go back to bed, fix the problem in maybe 30 minutes or less, go back to sleep. Congrats. Intelligent action is also what enables you to stop reacting to problems and start acting and fixing those problems before they actually occur. Now, at this point in the presentation, if you're anything like me, you're probably saying, hey, that sounds like a lot of, marketing talk. That sounds like great promises. So how exactly would an enterprise observability platform do that, Chris? And it does that based off of suggestions, AI, and deep analysis based on a curated knowledge base of things that have happened in the past. And so an enterprise observability platform ultimately has a knowledge base in it that says, hey, something like this has happened in the past. That's going to be a problem for you. You might want to fix it doing Y. And of course, Instana has one of those platforms that does all the things I just outlined in this presentation. It discovers maps and monitors services, infrastructure components in completely real time. It ingests all observability metrics that you can get from many other platforms out there, traces each request, and profiles every process. It creates actionable information and full context to enable DevOps teams to optimize their pipelines and applications. Once again, that might seem a little bit like marketing speak, and we went over this a bit at high level in this presentation. So at this point, I'm going to hand things over to my buddy Drew Flowers to show you exactly how we do that within the Instana application itself. Drew, I'll hand it over to you.
Awesome, thanks, Chris. So we have the presenter.
Should be all yours now.
All right. Now, Chris, can you just confirm the screen share is working for me? I don't have a feedback view here.
Yep, I can see it on mine.
Beautiful. All right, ladies and gentlemen, thanks for joining us this afternoon here in the States, or in the evening if you happen to be in Europe, or wherever you are today. Chris outlined 3 specific arenas that basically define what we believe is enterprise observability, and that's facilitated through automation, through contextualized data, and through intelligent action. So how does Instana solve these 3 exact problems, and what are we going to provide to any enterprise that actually utilizes our product? Well, It starts by understanding the way in which we want to contextualize the information, because it's not just about collecting metrics, traces, and logs, it's also about how you're contextualizing that info in relation to the rest of the environment. So effectively, what we're going to do here is we're going to start by collecting information from 4 distinct places. The first location is going to be your website and mobile applications. Anyone who's generating a customer-based app generally has one of these components, and it's very important to ensure they're up and operational so your customer experience is optimal. Now, the key here is that when we consume these transactions, we're also contextualizing and correlating them back to our backend application tracing. Now, the key here is that Chris mentioned facilitating automation as being key to observability, and for us, automating the path of instrumenting your code is very key. It's one of the first things that Instana was built to facilitate. So most of our tracers, with some notable exceptions like Go, are as automated as we can potentially make them, and in some cases, like Java, are fully autonomous processes. And those backend traces are contextualized to the front-end transactions that we see from the browser side, and we'll dive into that a little bit later in the presentation. On top of this, we need to understand whether the platform and the underlying infrastructure as well are both up and operational and performant as well. This is powered by our 1-second granularity metric collection. Effectively, what we're doing is trying to create a near real-time infrastructure monitoring tool that allows you to understand the CPU and memory utilization in context to say how your application is performing through distributed tracing. Now, platforms inside of Instana are defined as VMware ESXi, Kubernetes, including managed flavors like OpenShift and EKS, and of course, VMware Tanzu, formerly known as Pivotal Cloud Foundry. Infrastructure is going to be defined as virtual machines, worker nodes, and cloud-based services like your RDS or Cosmos DB in the Azure front. Now, to facilitate automation, we need to ensure that the system is as simple to deploy as we can potentially make it. Now, what this effectively means is that you don't have multiple agents to manage. You have one. That one agent can be deployed inside of Kubernetes, OpenShift, Cloud Foundry, now known as Tanzu, and of course, standard Linux, Unix, and Windows VMs, as well as Mac OS, so that your developers can utilize our system to code their process. Once that app is deployed, the agents are out, and they're actually discovering processes for you. What do we mean by that? Well, it means that the agent is designed to automatically discover the contents of a host, whether it's HTTPD, as you see here on the bottom left, or the Spring Boot apps down at the bottom. Our agent is designed to pick these out automatically, configure itself for monitoring, and report that inventory to our backend. Because one of the components that Chris showed and kind of talked about throughout his presentation is a core component of Instana that we refer to as the dynamic graph. Now, what that is this. And while this is not something that you're going to interact with on a day-to-day basis, it's very, very key to understanding how Instana works and how this facilitates context. Because in effect, what this is a real-time infrastructure dependency map of your hosts, your containers, your processes, your services, your endpoints, and how they all coalesce and contextualize back to each other. We know all of this data by virtue of infrastructure configuration and backend tracing, so why can't we stitch it all together? Now, while you will not interact with that map on any measurable way day to day, what you're actually doing is you do things like navigate through the tool here, is opening up the assets by navigating through the graph itself. Now, here on the infrastructure side, you can see those 1-second metrics that I was talking about, the high fidelity resolution that we're trying to create. This actually has 2 benefits, not only just for you to understand the peaks and valleys of your environment and performance impact at every level, but also for our machine learning, because anyone who knows much about machine learning or AI knows that quality of your data set directly correlates to the outcomes. You get garbage in, you get garbage out. So the higher the granularity of the data set, the better the outcome from the machine modeling. We also do this level of collection every step of the way, regardless of whether I'm looking at a Spring Boot application like this, or using Context Guide, which is a way in which we contextualize the environment and the entities underneath it at every single layer. What this means is that I can understand what this Spring Boot app is from an application context. What apps is it a part of? What service is it? And what endpoints are underneath it? I know what it is from my Kubernetes cluster, all the way down through the deployment in pod. And I know from an infrastructure context, what is the JVM underneath it? And I can even go back in through the Docker container itself, which also has that Kubernetes context pinned to the left and a whole host of information like the container labels. So if I'm sitting here wondering if this container is misbehaving, we'll just pretend there's some sustained throttle count right through here. And I want to check if the pod is being affected as a whole or just this one container, which is actually something that's remarkably difficult to do without a tool that contextualizes it for you. I can actually just use Instana to click from one point to the other. We carry the context from the asset that you were viewing through into the next screen, and we allow you to get into that data as quickly as possible. That's really the key. The more that you contextualize the data, the more that you create a workflow. The more that you create a workflow, the simpler this data set becomes for users of all levels to make sense of. So from here, not only do I understand the pod, I can see the pod's configuration specification, allowing me as potential management to run governance very quickly. I can see the entire namespace's cluster utilization across the board. And this is consistent, not just on the namespace level, but even things like daemon sets. So if you want to know what the Instana agent is costing your cluster on a day-to-day basis, it's very simple to extract that detail. Now, the key here as well is that we're also picking out things like the event role. So you'll know why your orchestrator is making the decisions it is, what assets it's impacting, and how that may have filtered into other problems down the line. So far, though, we focused almost exclusively on time series metrics, and APM really is the key for observability in this day and age. You might be asking, what is it that makes APM so incredibly important? And really what it comes down to is the fact that APM is one of the few things that you can deploy that will generate maps of your environment like this, allowing you to understand traffic flow, bottlenecks, and failures. And using a tool inside of Instana that we call application perspectives, you're going to get a very quick and easy to deploy dashboarding system that presents to you a standardized workflow. What this means is everything I'm about to show you is fully out of the box functionality. In fact, all of these product components on the left are out of the box. This didn't take us months to build up. So when we build out views like this for my robot shop, understanding all of these services and all of this infrastructure, including the hosts, my containers, and my clusters, how do we do it? We simply asked you to use some tags that exist in your environment already by virtue of the data that we collect and tell us how you want to view it. No more SQL-like query languages, no more generating your own dashboards, no more creating widgets. Just tell us what you want to see. And in this case, we looked at 2 namespaces and a service. And this captured my containers and my hosts automatically. App Perspectives is fully aware of the underlying infrastructure. It also knows what are the log messages that are going through the system, because as a byproduct of our instrumentation, we instrument your logger at the same time, and we grab any message of a warn level or higher and bring it back into the system. This allows us to understand trends in error rates and potential root cause, facilitating that intelligent action that Chris was talking about just a few minutes ago. So what else does AP allow me to do? I mean, right now we're kind of high level, right? I'm about 10,000 feet in the air. I'm seeing my app as a whole. It's kind of like looking at Google Earth and hovering above New York City right now. What I want to do, though, is pretend that I'm a Java engineer. And you know what? Looking at the front end summary of this, I kind of want to know what in the world is going on right here. This sudden spike in my error count that is also showing me a jump in latency, a jump in processing time, and a reduction in my throughput. Using application perspectives, I can generate a simple curated workflow that allows me to key in on the one service I care about, which today is going to be the catalog demo service as the Java engineer for the DevOps team. Drilling into this service, you'll notice that same standardized summary that you saw on the front is consistent here as well. This is very key. One of the main problems with adoption of observability tools and that excess customization that you see required by other products, the fact that really only the person who built the dashboard is the one who understands how it works. But if instead of using non-standard terminology and instead going on things that the Google SRE handbook identified as the golden signals, throughput, latency, and error rate on the performance side, SLO on the back end, we can actually standardize the workflow as well under those golden signals and simply application, service, and when I drill into an endpoint, my endpoint. Now, why is that key? Because a lot of APM tools, once you've figured out what your service and your endpoint that's failing is, they're going to ask you to switch gears. Go to something like our analytics mode over here. Throw out your query by hand, start looking at the raw traces and figure out what's wrong. But this is another inefficiency in the space. If we already have all this data, if we're already contextualizing it through the dynamic graph, why are we forcing you to generate a query when we can actually just visualize the entire chain? Using that endpoint as a context and the dynamic graph correlation to map the entire API endpoint point to point. Using throughput, latency, and error rate underneath every single hop, you just simply follow a visual chain until you find a break like this. I have a connect statement under my SQL DB that's failing 100% of the time. When I click this endpoint, Instana carries the context again, maintaining the app that I'm looking at, so I'm not jumping into a database that's disparate from what I'm doing. And I can simply look at the error messages affecting the environment. There's my root cause. Now I have the information I need to take the intelligent actions that Chris was talking about, but there are other ways we can keep facilitating that intelligent action. If I click this message, you'll notice we did jump over to analytics, but hey, my query got generated for me because Instana understands the context of the actions I'm attempting to perform. When I pull open a trace that's relevant to what I'm exploring, you'll see most of this is standardized on open source standards. Much like Chris, we are big open source fans. We contribute to the standards, and a lot of what we do is derived based on historical standards. We have applied some kind of instanification, as I like to call it, to some of the way in which we display this data. This right-hand panel does adjust every time you switch spans, so it will contextualize what you're looking at. The profiler that we have, which is an always-on system, it takes profiling snapshots rather than profiling at every second of every minute, also pins some state and time info. So if this was a long-running call not derived from error, you could see if maybe one of my methods just smacked the CPU a little too hard. At the same time, we understand the full infrastructure. Here's the catalog app that originated this particular call, and here's the discount app that it jumped into. And the stack trace here, you may have noticed, has some clickable links. When I hit this, we're going to decompile the code of your instrumented service live and expose it temporarily to our backend. And in effect, what I like to describe this as is going from that dependency map view, kind of that pie in the sky Google Earth view right above Manhattan Island, diving directly down into a block by block street level interaction, our own code. And we're able to facilitate this all inside of one UI, utilizing just a hefty dose of automation. We also have the error logs down here. So if I need to know what all the issues were, I can just click into them individually and even see on the time span where these error messages were generated. So I know exactly in my transactive timeline when and where the error occurred. Now, one of the things that folks might be wondering is, hey, Drew, you just found a big problem in MySQL. It's hard down. Shouldn't that have been an alert? And in fact, it was. Going through with what Chris was saying, we come out of the box with a curated knowledge base of over 250 events. These are derived from what our technology partners believe to be best practice of how you should monitor something out of the box. We do, of course, allow you to create custom threshold events for things that are more specific to your environment. From here, you can, of course, send these alerts to any alert channel, email, Slack, OpsGenie, PagerDuty, all the standard stuff. But when we generate events, we want to apply some intelligence to what's actually happening. And in order to do that, that means we need to understand 3 different types of events that occur in any environment. We're going to have change, things that impact the system, like container labels that change as a byproduct of discovery, or online-offline events because the orchestrator is busy and responding to changes in traffic. Issues are going to be low-level problems, things like one endpoint having a sudden uptick in latency, but maybe it's not affecting the app as a whole, it's just one specific request, or maybe we have CPU usage bubbling up to a problematic level. Not quite an error yet, but it could become one. A lot of things that you see here may not be actionable for you at the time they're generated, but Instana creates a lot of events because whenever an incident fires, we want to have context for what could be the underlying issue. Incidents are the highest classification of event inside of Instana. This is where our machine learning and AI-based systems are trying to let you know that there is a significant issue impacting more than one service and customers are likely having difficulty utilizing your tool. This is where we want to apply some intelligence. Any tool can tell you there's a sudden increase in the number of errors on this one service. Good luck, God bless, go figure it out. Instead, though, we have this dynamic graph. We have all this contextualized data, and we have every single request going through your system. So why can we not further contextualize these events with something that looks like this? What you have here are 10 individual problems tracked to one change that affected 4 infrastructure or application entities. So in effect, what you're seeing here is one event instead of 10 individual alerts that you had to piece together yourself. This is what brought me here. My catalog demo service bubbling up to about 16%, give or take, on the error count. Why this is anomalous behavior is because we do evaluate on a 30-minute window, and prior we were down to 0%. So this is obviously something that has not been happening prior. On top of this, we noticed a latency spike of about 2 seconds. Curious, right? On top of this, discount service saw similar problems with error and latency, and ditto MySQL down on the back end. The important piece, though, is that prior to all of this occurring, we tracked a change on MySQL where it went down on this specific host right here. And that change was also an abnormal termination detected by our eBPF sensor as a SIG kill. So this was not a graceful shutdown. Someone either did this intentionally or maliciously. We have a problem with our database and we need to bring it back up as soon as possible. And these related events are organized in a way to basically create a checklist. Start with SQL and work your way down until no further problems exist. The last thing I want to show you here is our end user monitoring portfolio, because again, customer experience is key to any business operation. And what is that magic number they say before a customer tunes out of your website? 3 seconds. So if we are above 3 seconds in paint time on your page, you've already lost probably 75 to 80% of your customer base. That's problematic. EUM allows you to track those changes and understand how your customers are being impacted at every level, whether it's page views, transitions, load time, JavaScript errors, or geographical distribution of where the traffic's coming from. Of course, you do get things like paint timing, the resource loads, and all the listed JavaScript errors. But how do we contextualize this data further? Well, by simply giving you a copy and paste script, and with a few modifications, you can perform some actions I'm about to show you. Why I say a few modifications is because what I'm about to do requires the exposure of usernames that are accessing your system. What you need to understand is that by default, Instana does not do this. That would be a violation of GDPR if we pick that data out automatically. So I do want to be transparent with folks on the webinar. What I'm about to show you does require a slight customization to the script that you are viewing, but it's not terribly difficult to do. Once you plug that in, let's pretend that somebody's calling me up and saying my site is being outrageously slow. I can simply look up their username, in this case, Tommy Huggin. When I do so, I can see immediately that we have one page here that is jumping out on load time by a factor of over 2x, going from previous highs of 189 milliseconds to 460. On top of this, we have a 2-second call that very recently came in, perhaps the genesis for Tommy's phone call to begin with. Let's expand this page and take a look at what's going on with one of those 2-second calls. Now here is basically what you expect from an end user monitor. However, this user info right here, this is the customized piece. This does not come by default. Browser info you see here in user location does. Now, when I'm looking at these resource loads, we can see immediately that most of my CDN calls, CSS sheets, PNGs, they all came in relatively quickly. It's really this root call right here, the original, that generated all of the resource loads underneath it. When I expand it, DOM only accounts for roughly 307 milliseconds of time. This does not account for why this took 2.2 seconds. So we have the eternal question. Was this a byproduct of my customer having a 4G connection in the middle of Arizona? Was this a byproduct of network latency in between their cell signal and me? Or was it my backend that caused the problem outright? Instana takes these two views of the backend and the front end and allows you to jump between them with one push of a button. This is how we contextualize that user data to your backend trace, so you can find out very quickly that poor Tommy is being impacted by the same issues that we've been seeing prior, where we just cannot reach that MySQL database through catalog. Ladies and gentlemen, that is what Instana tries to provide. Much like Chris was saying in his earlier presentation, it's about 3 key things: automating the implementation of the tool and discovery of the data, contextualizing it so you understand what this information means. What did the backend trace do that created problems on the front end? And how do you facilitate intelligent action through heavy correlation, machine learning automation, and an intelligence in the event view that helps you understand whether something was a change, a little problem, or a big problem, and then contextualizes everything so you only get one event instead of 10, 15, or 20. Now, I do know we have about 20 minutes left of the scheduled time of the webinar. If you have any questions, please do drop them in the GoToWebinar piece over there. We're more than happy to answer anything you might have. And with that, let's bring Chris and Dave back into the conversation, as that does wrap up the demonstration.
Thank you, Drew. Appreciate that. Excellent presentation, fellas. I think that really showed all the value that people can get out of using enterprise observability and why they should be doing that kind of thing. So I thought that was great. Let me just start off with a couple of quick questions that we have received. One of them pretty simple. I guess I'll throw this out to Chris, and then if Drew wants to add on, that would be fine. So the question, a simple one, is Instana cloud only, or can it also be used on premises?
Nope, it can be used both, cloud and on-premise.
Mm-hmm. And the person also wants to know what cloud
Mhm.
providers are supported by Instana.
So we support all the major cloud providers, so AWS, Google, so on and so forth. We also support Oracle Cloud, IBM Cloud. I guess I should lay out all the major cloud providers, right? So Amazon, Google, Microsoft, I believe also Microsoft Cloud.
Azure, yeah.
Drew, anything I'm missing there?
So you pretty much got it. Instana does
Perfect.
support all major cloud providers. We have managed service ingestion for AWS, GCP, and Azure, and we are working at bolstering our support now that we are owned by IBM for the IBM Cloud as well as Oracle. So do expect to see that expand in the future.
Mm-hmm. Great. So one of the things that I was curious to dive into a little bit, which seems to be something that comes up a lot in our coverage of the topic, and that is people, I think, have a little difficulty kind of differentiating between what, APM, application performance management, is, and then compare that to observability. And I think there might still be a little misunderstanding there between what the difference is. And Chris, maybe you can, wax on that for a minute or so.
Yeah, sure. Actually, I will divert that to Drew if you don't mind, Drew.
So from my standpoint, it's actually a pretty simple explanation. A lot of people overthink what it means for observability versus APM. What you need to think about is observability as a high-level idea. It is the concept of taking multiple monitoring locations and feeding them into something that can contextualize and intelligently correlate the data. So APM is a foundational component of any good observability platform because it's going to cover that backend application stack. But unless you have something that is monitoring the infrastructure, the platform, and that front-end customer experience, you only have one component. You have APM. You do not have observability.
Right. Good. How do you actually observe the end user and their experience? I know obviously one way would be direct feedback, like they either leave your site or leave you a nasty message on a social media platform. But beyond that, are there other ways that you guys can collect pieces of the user experience to determine how things are going?
Absolutely. I mean, that's exactly what the end user monitoring portfolio of Instana is designed to do. That little piece of JavaScript that I was showing towards the end of the demo is basically designed to dig into the user's browser and understand the performance impact from that side. Now, of course, you can also bolster this with other functionality like synthetics monitoring for a more proactive customer experience stance. And there are other tools as well that are coming out, like what they refer to, I believe, as customer experience management, which is
Mhm,
kind of another analytics layer on top of what you're seeing from that. So
mhm.
there's varying tools to facilitate it. From our standpoint, as one that's very focused on, on enterprise performance management, we think EUM is the most comprehensive way to pull that off right now.
Mhm. Interesting. Okay, I see we have another question from an attendee who says that they're using a lot of AWS services and are
Mhm.
wondering which are supported out of the box with Instana.
A whole
Yeah,
mess of
absolutely.
them.
So, I guess I'll take that and then I'll give it off to you, Drew. Yeah, like Drew said, it's a whole mess of them. The easiest way to go about seeing the massive slew of them is to go to our docs, hit AWS services and Instana, just Google it, it'll show up. It's literally, I'll name a few off the top of my head. Beanstalk, EC2, Elasticsearch, DynamoDB, Lambda, ELB, uh, the list goes on forever.
Fargate,
Uh,
SQS, SNS, you name it. The list is
there
expanding
you go.
all the time because anyone who exists inside of AWS knows they're adding features faster than any vendor can keep up with watching them all. So we don't have everything. I mean, unfortunately, we're not monitoring the AWS satellite launch console, but for most of the stuff that your application stack is using, your SQS, your S3, your ELB, we've got you covered. And if you see something missing, let us know. We're always taking customer feedback back to our PM org.
Great. So just a reminder to our attendees, this would be a last call for questions as we're kind of coming up on the hour. But so before we leave, I would like to throw it out to both Drew and Chris to sort of summarize if there's one important takeaway that people should take, from this session. What would be the most important thing for them to leave here with?
Well, I can, if you don't mind again, Drew, I'll slice that and then you can take your key takeaway.
By all means.
So my key takeaway very succinctly would be that enterprise observability really boils down to those three main concepts. It's intelligence, context, and automation, or intelligent action, automation, and context. That's enterprise observability in a nutshell. Drew?
What I would actually impress on folks is not so much what did the content of the presentation show you, but rather what are you missing in your enterprise stack and what inefficiencies is that creating for you? Like Chris talked about in his presentation, we've all lived and dealt with the 3 a.m. problem. And we've all dealt with war rooms where you've got 30, 40 people on the same line trying to figure out one issue. A lot of times in my experience as an IT engineer and data center guy for a long time, these things are derived because a company is not invested in their toolkit to the degree that they should. A lot of these things like APM, EUM have been seen for decades as extraneous costs and questionably useful. But now that you have things like containerization, microservices, Kubernetes, and a sprawl that is getting bigger and bigger in every enterprise cloud by the day, it's becoming imperative that you have tools that understand exactly what's going on. Because the less that you wake up 40 people at 3 o'clock in the morning and instead wake up 2 people who are the exact ones to fix a problem, the better outcome you're going to generate for your business and the more money you're going to wind up making in the end. So as you see the things that we've shown you and you understand the concept of observability, ask yourself, what am I missing and how is that affecting me?
Good stuff. Very good. Thank you. So Drew Flowers, Chris Lentrichia from Instana, thank you for being with us here today. As I said, I thought this was really a great look at the concept and the reality of enterprise observability. Certainly would like to thank Instana today as well for sponsoring today's session, and to thank all of our attendees who hung in there with us today and hopefully had a lot of good information to absorb. So until next time, I'm Dave Rubenstein, Editor-in-Chief of SD Times. So long for now.